Assalamu alaikum and welcome to Cambridge Chemistry channel by Sarwat Ahmed. Today I will discuss paper 4 May June 2022. Let's start. A student determines the concentration of aqueous potassium manganate KMnO4 by titration with a solution of ethane dioic acid H2C2O4. An equation to represent this reaction is shown. KMnO4 plus 5 ethane dioic acid plus 6 hydrogen ion 2 manganese to form manganese ion carbon. This is redox titration. Whenever potassium manganate or any oxidizing agent react with any other reagent, so this will be act as a reducing agent and it is oxidizing agent. So this is redox titration. It is redox titration. Uh, Diagrams of some of the pieces of apparatus the student uses are shown. So these are the common apparatus used in titration. Name of these name the three pieces of apparatus. A is burette, B is pipette, and C is conical flask. The student records the mass of sample of ethane dioic acid, dissolves the solid in distilled water and makes the solution up to. Students, this is very important to know the summary of the solution, summary of this question. Records the mass of sample of solid ethane dioic acid, dissolves this ethane dioic acid C2 H2O4. H2O4. This is ethane dioxide dissolves in small amount of and then dissolve the solid in liquid distilled water and makes a solution up to 250 centimeter cube. Now transfer this solution in volumetric flask. This is the type of flask which is known as volumetric flask, and transfer this in this flask, and this flask is about 250 centimeter cube. Now transfer this solution in this flask and uh, makes a solution up to 250 centimeter cube. So this is the solution of 250 centimeter cube. Uses apparatus B to transfer 25 centimeter cube. Apparatus B is the pipette, and pipette is used to transfer 25 centimeter cube into apparatus C into conical flask like this flask. With the help of pipette, it is transferred into conical flask. Add 10 centimeter cube of dilute 10 centimeter cube of dilute sulfuric acid to apparatus C. First add H2CuC2O4 with the help of pipette, then add 10 centimeter cube. This is about 25 centimeter cube and 10 centimeter cube of sulfuric acid. Fills the apparatus A with the solution of KMnO4. Now in burette, KMnO4 will be taken. This is the burette, and now solution is going to reaction is going to start. Fills apparatus A solution KMnO4. Over here KMnO4 whose color is purple. Titrates the colorless solution H2C2O4 with the solution of KMnO4 until the end point is reached. Repeat the titration 3 more times. Suggest why the sulfuric acid is added in apparatus C. Suggest why sulfuric acid is added to apparatus C. Why sulfuric acid is added to apparatus C? To acidify the solution, or we can write down to provide hydrogen ion state the color change at the end point from the color change is from colorless. In the flask the solution is colorless. H2C2O4 is colorless, so the solution colorless to pink. The diagram shows parts of apparatus A with the liquid levels at the beginning and at the end of titration 1. So the final burette reading, this is final burette 27.1, this 27.1, and this is 1 2 3 4 5 6 7, this is 1.7. This is 1.7 and the answer is 25.4. This is round about 25 point, this is equal 25.1, and if 24.6, the answer is initial reading would be 0.3. Take the best titration results in the table. Use the ticked value of the to calculate the average volume of KMnO4 added in centimeter cube. So we must take two closest reading. So 24.8, 25.1, 24.6. So reading 2 and reading 4 is the difference between 0.2, but while 25.1 and 25.34 is the 0.3 difference. So we must take 24.8 and 24.6, whose difference is 0.2. The take the best, try to use the ticked values to calculate the average volume of KMnO4 added in centimeter cube. So this is 24.8 plus 224.6 divided by 2. The answer is 24.7. Another student repeats the experiment using the same method. This student uses 1.08 gram of ethanedic acid to make up to 250 centimeter cube solution H2C2O4. The student obtains an average titration volume 24.55. Calculate the number of moles of ethanedic acid in 25 centimeter cube of the H2C2O4. Number of moles of 25 centimeter cube. So number of mole is NC2O4 is equal to 1.08 divided by 90 is the MR, and answer is 0.012. 25 centimeter ethane moles of ethanedic acid in 25 centimeter cube of H2C2O4 aqueous. Okay. So 0.025 centimeter cube, 25 centimeter cube containing 0.012. So this is volume ratio mole or mole ratio volume. Then 250 centimeter cube contain X. So answer is 0.012 divided by 25 into 250. Cross multiply and the answer is 0.0012. So 2 moles of potassium manganate react with 5 moles of H2C2O4. So calculate the number of moles of KMnO4 in 24.55 centimeter cube of the aqueous solution of the aqueous potassium manganate. So the mole ratio 2:5 and 0.0012 ratio x. The answer is 0.0048. Calculate the concentration in mole per dm cube of the KMnO4. Concentration is equal to mole over volume into 1000. Mole is 0.00048 and the volume is 24.55 into 1000. The answer would be 0.0196. Calculate the concentration in gram per dm cube of KMnO4. Give the calculate the concentration. This is mole per dm cube. Gives your answer in gram per dm cube of KMnO4. This is mole per dm cube. Is 0.0196. So you convert gram per dm cube. So mass is equal to mole into mR158. The answer is 0.0196 into 158. This is equal to 3.09. So 3 significant answer is in 3 significant figure. A solution contains one cation and two different anions. The table shows the test a solution does on this solution. To 1 cm depth of solution in test tube, add a small volume of aqueous sodium hydroxide. The cations might be aluminum 3 ion. The cations could also be small volume of aqueous sodium hydroxide, white precipitate, then add more aqueous sodium hydroxide until it is in excess. White precipitate, dissolves. The cation could also be and the dissolved cations are uh, zinc 2 positive or aluminium 3 positive or lead 2 positive. So the cation could also be zinc 2 positive. To 1 cm depth of solution in a boiling tube, add very small amount of aqueous. The cation is aluminum, white precipitates. Then add more aqueous ammonia until it is in excess. White precipitates, insoluble. To 1 cm depth of the solution in a test tube, add nitric acid and warm until no further change is seen. A gas is evolved that decolorizes acidified magnesium manganate 7 solutions. Add nitric acid and warm until no further change is seen. So this is sulfur dioxide. The gas is sulfur dioxide. One of the anion is sulfitine, SO3 2 minus. The solution from 3. The solution from 3 add aqueous silver nitrate. A yellow precipitate forms. The other anion is iodide. Or a mixture of solid contains barium sulfate and sodium chloride only. Barium sulfate is insoluble in water. Sodium chloride is soluble in water. Describe how to separate the mixture to obtain pure barium sulfate and pure crystals of sodium chloride. Describe how to separate the mixture to obtain pure barium sulfate. A mixture of solid contains barium sulfate and sodium chloride. And water, beaker containing barium sulfate and sodium chloride. Mix the solution with glass rod until barium sulfate is settled down in the bottom, while sodium chloride dissolved in water. Filter the solution to remove barium sulfate as a residue on the filter paper. Wash the residue with distilled water and dry the residue in folds of filter paper. Heat the filtrate till saturation point. Allow the crystals to cool and dry in folds of filter paper. A student measures the temperature change during the reaction between HCl and aqueous sodium hydroxide. The student chooses a measuring cylinder to add 25 centimeter cube of 1.50 mole per dm cube sodium hydroxide to a glass beaker. Records the temperature of the sodium hydroxide. Add 4 centimeter cube of the HCl to the beaker and records the highest temperature reached. Add further 4 centimeter cube portion of HCl and records the highest temperature reached each time. Okay. Name the type of the reaction that takes place between HCl and sodium hydroxide. This is neutralization. Name a piece of apparatus that can improve the accuracy of the volume of sodium hydroxide aqueous added to the pipette. Name the piece of apparatus used to add the 4 centimeter cube portion of HCl burette. Explain why the glass beaker is not the most suitable piece of apparatus for this experiment. Suggest an improvement. Explain why the beaker is not the most suitable piece of apparatus for this experiment. Heat loss. Heat loss. Glass beaker is not the most suitable as heat loss can be from the glass beaker. Okay, improvement: use a polystyrene cup or plastic cup can be used, or you can insulate the beaker to minimize the heat loss. Now plot the values of temperature against total volume of HCl on the grid. So first 24.5, here is temperature, over here is volume. 24.5, this is 24, and over here you can use dot and cross. You can do either dot or cross. 1 2 1 2. So this is, and next value is 24.5, 25, 25 at 4, 25 at 4, and next value is 28.5 at 8, 28.5. This is next value, and at 12:30.5, 12:30.5, 1 2, this is 30.5, and at 16:32.5, 16:32.5, 1 2, this is 32.5. Now at 24:31.5, this is 24:31 point, this is 24:31.5, and 28:30.5, 28:30.5, 1 2 and 3, this is 20:30.5. This is 31.30.5, 31 at 31.5 at 24, sorry, this is wrong, at 24, 31, 31 point, 24:31.5, this is 24:30 point. 1 2, this is 31.5, and 8:30.5, and now at 3229.5. 3229.5. This is 29.5. Now circle the anomalous point on the grid. Draw a straight line of best fit through the points from 0 to 16 centimeter cube. So this is the best fit line. Best fit line, and extrapolate. This is the best fit line, and draw a straight line. Circle the anomalous. This is the anomalous value. Draw a straight line, the best fit from 20 to 32. Extrapolate both lines so that they intersect. Use the intersection to determine the minimum volume of HCl needed to react with all of the NaOH. So this is the minimum value, minimum volume. So this is 18, 16 and 17. So in the middle of the 5 line, this is 17. This is around about 17.5. Okay. Use the intersection to determine the temperature change delta T due to the reaction. Delta T is final point is 32.5 and initial point is 24.5. So this is 32.5. So this is the final temperature. This is 33.5. 33.5. 33.5 minus initial temperature is 24.5. 24.5. So the answer is 8.7. The heat change during this reaction is calculated using the expression shown. Heat change is equal to mass of solution into specific heat capacity into temperature change. 1 centimeter cube of this solution has a mass of 1 gram. Specific heat determine the value. Okay. Determine the value used for the mass of solution in the calculation of this heat change. So the total mass of solution is, this is 17.5 volume of HCl, and sodium hydroxide is 25. So this is the mass, and the actual heat change of this reaction is much greater than the value calculated using the expression in A9. Suggest a reason for this difference, that is due to heat loss. Question number 4. The apparatus shown is used for the electrolysis of dilute sulfuric acid to produce hydrogen gas and oxygen gas. The apparatus The electrodes are made of platinum. Give the name of each electrode. Positive electrode is anode. Negative electrode is cathode. The equation for the reaction at the positive electrode is shown. Give the equation for the reaction at the negative electrode. At negative electrode, hydrogen ion discharge at the cathode gains electron to form hydrogen gas. Describe test used to identify the gases produced. Oxygen gas. Take glowing splint near the gas jar. Oxygen gas. Relight the glowing splint. Hydrogen gas. Take lighted splint near the gas jar. Hydrogen gas produces pops in flame with lighted splint. The student uses the apparatus shown to investigate the rate of reaction between excess copper carbonate and dilute sulfuric acid. This is the reaction. Carbon dioxide is gas is produced, which is this is bung, cotton thread, and this test tube containing copper 2 carbonate. This is dilute sulfuric acid. So identify the piece of apparatus labeled as gas syringe. The student starts the reaction by tipping the sample tube so that the copper 2 carbonate and acid come into contact. Explain why this method is used instead of adding copper 2 carbonate to the acid and then replacing the bung to avoid the loss of gas. The student takes recording on the apparatus X every 10 seconds until the reaction has stopped. The students plots a graph of the result. Horizontal axis time, second, and vertical axis volume of gas, carbon dioxide, centimeter cube. Time in second, vertical axis volume of hydrogen gas. These three things the student sees happening in the flask during the reaction. Solid disappears, effervescence of gas, solution turns blue. Use the graph to explain what happens to the rate of reaction during the reaction. Rate with the passage of time, rate is going to decrease. Rate decreases because the concentration of acid is used up, decreases. So decreased and gradient also decreases. So this is all about of this paper. Hopefully you understand this. If you like this video, please if you like this, subscribe the channel and like the video.